Welcome to part 2 of our 2-part series where we talk about tips and tricks that we've learned that you can use to make your annual maintenance go more smoothly. If you haven't seen part 1, check it out. It's in the link above. So let's get started.
One of the maintenance items that we had to do was replace a coaxial cable that went up to the top of our mast to the antenna. We had a lazy sheet that was under pressure and it crossed on top of our coaxial cable and crushed the coaxial cable. What happened, if you'll look down here, we have this stainless steel metal loop here, and what happens is all the electronic wires that have to go up to the mast come through the bottom of the boat and up inside this, and then comes down, and you can see that they're all exiting on the other side of this loop. And then these wires, they meander for about 12 inches, and they actually go inside this is the mast, and they go into a hole on the other side of the mast, but it's a hole just like this, and then those lines run all the way up to the top of the mast. So we have a VHF antenna wire, we have electrical wire to the lights that go up, we have the wind vane meter and the wiring for that, we have a VHF antenna, we also had an extra antenna for our AIS, and we also have radar, both power cables and data cables for our radar. So all those wires have to come through this loop and into the mast. And what happened was our sheet attached to our head sail, the lazy sheet that is, when we went and tacked, the lazy sheet was under some pressure, and this sheet actually laid on top of one of our coaxial cables and crimped it enough that it broke the shielding in the coaxial cable, greatly reducing the power transfer within the cable, and then basically we had very little communications with our AIS and our VHF radio. So we've since fixed that. But to make sure that that never happens again, meaning this lazy sheet causing one of our coaxial cables to break, what I ended up using was some Amsteel line. So I wrapped this Amsteel gray line between the metal loop here and the mast and built up a guard here. So if this lazy sheet lines along here, it'll climb up the metal, it'll run across the new guard I've created with this line, and then put its pressure up against the mast, and it'll never be able to go and crimp any of these lines anymore, which now is a fantastic solution. I also got one other really valuable piece of recommendation when I was looking at a solution like this. I was considering putting a metal bracket instead of using gray line. I was told by the electronics manufacturer, don't use another piece of metal to connect between stainless steel and aluminum. You just cause a lot of metal on metal effects. And in sailing, you try the most you possibly can to make sure that different metals don't touch one another in saltwater sailing areas, because when you do that, the galvanic reaction can occur between the two metals, and the ultimate outcome of galvanic reactions is the metals actually deteriorate and salt away, if I understand the process correctly. But with that smart recommendation, we just went to this Amsteel line that's very strong, doesn't chafe hardly at all, very slick, and it's been working very well, protecting all of our cables.
One of the other boatyard details that we had done was taking out a coaxial cable that ran up our mast to our antenna that we had crimped. We didn't need to replace that coaxial cable, but I knew it was broken and would not work again. We found out that the real fix was, instead of running 2 antennas up at the top of our mast, we could run both our VHF and our AIS off of one antenna, and the software in both of those units would hand off the use of the antenna. Before, we had an AIS unit and a VHF unit running 2 different antennas, and they weren't coordinating with each other, and so the 2 antennas were actually canceling each other out. So we went to one antenna, which worked, and everything's been working since then. But since we had the second antenna up there, it could perform as a backup antenna as long as we fix the coaxial cable. So while we were at the boatyard, the guys went up to the top of the mast and pulled in a new coaxial cable back to the second antenna and brought it all the way down, took the old coaxial cable out, and now we have a secondary antenna basically dead-ended back behind our electronics. As a side note to fixing the coaxial cable, I got back to the boat and I saw this massive crane over our boat, and the guy who was pulling the cable was actually at the end of the crane hoist, and so instead of him just climbing up the mast, he was actually using a crane. And all I could see was a big dollar sign, and they started laughing and they said, no, we use the crane ourselves just because we like to do it. It's easier and it's safer, but we don't charge anybody for this type of crane use. They were charging us a fixed rate for getting the wire taken care of and getting the second antenna as a backup for us.
So our last step on our annual maintenance was getting our boat compounded and waxed. We got this done by a detailer, we didn't get it done by the boatyard, but I'm going to give you a little cautionary tale as far as what we did that you're not going to want to repeat. You have to be realistic with what you're willing to do. Somebody had went through and showed us how to do the whole buffing and waxing ourselves, and we got the products and we also got the buffer, and the inside I was going to do all by hand. So I was going to leave the hulls to Jim and I was going to do all the other surfaces. As I said, we bought an electric buffer as well as all of the attachments for the electric buffer so you could actually do the compounded, and we bought the 3 compounds from 3M so that we could do the buffing ourselves, which is the cutting compound, the polishing compound, and the waxing compound. And I use this and I think these work quite well, but the problem was I did all of the inside surfaces and the hulls, which were supposed to be done by Jim, using the buffer that we paid all this money for, 0. So unless you actually are realistically going to do all that buffing, don't bother. Just get it done professionally. This year, I put my foot down and it had to be done. It was looking horrible. So we ended up getting it done professionally. And what they suggested was that, because we said we wouldn't be able to get back for probably 8 months to a year, so they suggested what we do is that every 3 months we use this Colonite product. It's Colonite Fleet Wax. So I got out here and I've done all of the hand surfaces on this interior portion of the boat, and the hull hasn't been done yet, but I'm crossing my fingers since all he has to do is get out and do a little hand waxing and wiping that it's going to get done. But don't wait, get it done. Some people get it done every 6 months, but with doing this small portion by hand, we should be able to go for a full year. And this is 3 months, and I just did it, and it looks wonderful still. So I think we're going to be able to get away with a whole year.
While in the boatyard, I probably had 6 people ask the same question. What is this line along the keel? And at first blush, I think a lot of them think that there was something broken with the keel. But you'll notice that both keels have the same exact line. What this is called it's called a sacrificial keel. And this is the bedding or Sikaflex in between the weighted keel and the fiberglass. And you can see here that it is mated. The actual keel is mated to the hull in a way that's called sacrificial. And we were actually in Dania Beach years ago when a brand new boat that had unfortunately been dropped in its movement had to have its keel fixed. And because it was a sacrificial keel, the accident that happened was much smaller for that vessel, which had a sacrificial keel, than the average boat. And what I mean by that is, so this keel is manufactured, it's heavy and it's solid, but it's manufactured with big bolts that come vertically out of the keel. And the hull itself is built with the ability to mate those bolts inside here. And what they do is they put the keel on, and they have a hole drilled right here and a bunch of places where they can get the nut inside, screw it down, suck down the nut to hold the keel to the rest of the boat, and then they fiberglass this over and clear it up. What it means is there is no bolts that come into the hull where we are. And if you ever hit anything with this, you're much more apt to crushing both the keel and this sacrificial area right here, and not actually crack open your hull and sink. And so this line right here is nothing more than delineates between the sacrificial keel and the bolts that go up into the hull area right here, which when you see these things pulled out and they literally lower the vessel down to the bolts, and then you can see the bolts through these holes in the side of this area, and you just put the nuts down, suck it down, and then clear it up. It's really simple compared to literally having to refiberglass the entire hull because you broke this off under a really bad accident. And by the way, we've never done anything other than touch sand with our keels. We've not hit anything. We've had the boat for 3 years, and our last handover issue has been dealt with. It took a while for a whole host of reasons. This window right here at handover at the very corner had a hairline crack that started here and moved out. It moved out about 4 or 5 inches, and it did not crack all the way to the edge of the window. The fix for that was, first of all, to get a replacement window. These are very unique windows. They're built specific for each boat, and you cannot get them made pretty much anywhere else. And so it took a year and 4 months for the window to catch up to us. Once we had the window, there is a very specific standard operating procedure to put the window in. The first 2 boat yards, we showed the standard operating procedure. We showed them the window and what needed to be done. They politely passed on actually getting the window fixed. So as a side note, boat yards are on the hook to all the work they do because they guarantee their work. So if they fix a window and then it ends up breaking or not performing to expectations 6 months down the road and we're 1,000 miles away and we've got to get another boat yard to help fix it, the original boat yard that did the work is on the hook for that and may have to pay the new boat yard to help get it fixed. As a result, boat yards, when they see something that they're not used to, they'll either pass on it, or if they are willing to do it, they'll jack up the price because they're worried that even though they're doing the best they can to fix it, they also know that they're providing a warranty on their work. So we had to wait almost 3 years before we found a boat yard and the time to actually get the window taken care of. The group did a great job. If you can imagine, they took this port out, they just unscrewed these screws and took it out, and then they took a sawzall and started sawing down this plexiglass window out to the edges, and then started peeling away these triangles of window until they got it all off, because the glue and the way it's put on is pretty beefy. And then they cleaned it, did the standard operating procedure to putting the new window in. We waited the 7 to 10 days of curing time, and now it's perfectly put in. One of the core reasons why the other boat yards said no to the window was when you put all the glue on the outside of this window and then press this plexiglass window up against it, you have to basically put a set amount of pounds per square inch lateral pushing on the window so that the glue and the window press up against each other hard enough that as the glue cures, the window is pressing the entire time. So what that required them to do is, with a bunch of lumber and some leverage points outside, they had to build kind of a contraption that went up against the window and then pressed against the window, and they used a bunch of shims to adjust the pressures on the outer edge all around the window so that there was a correct standard operating procedure amount of pressure for the set number of days as the glue cured. Also, as I noted, that the crack started here and moved out, and it did not go to the outer edge. For the 3 years we had the boat, and all the weather conditions and all the different poundings and rocking of the boat and all that, this window never cracked to the other edge. So it stayed in that 4 to 5 inch hairline crack, and it never propagated to the other edge, which is really a great feeling because it meant that our boat was not racking and not putting a lot of undue stress on this window for the 3 years. What most likely happened, by the boatyard's opinion, is that when this port was put in, the way this hole was originally cut, the corner right here was at a very sharp 90 degrees. They didn't put any type of nice bull nose to that cut in the corner here. And when they tightened this down, Possibly what happened was one screw and another screw didn't line up, and it just ended up starting a crack right along here, and that's all there was to it. It's been in for 3 months. It's sturdy. It looks very nice. They did a great job, and it's all over with. I did the craziest thing that probably I have not seen on any other boat.
I see it already.
Exactly. We put our underwater lights only on one hull. So let's explain why we did this, and at least it'll be documented, so when we turn it on in the Bahamas and we see how it works, we'll either be really happy or we'll know who to blame.
Well, you know what we can do then is if you like it, then you just put it on the other hull as well.
Ah, there you go. I can balance it out. We have 2 lights right here.
Right, I'm going to come in and check them out.
Right.
There's the one.
Right.
And there's the other. Wow, that's crazy.
Yeah, and we made sure that the rudder and the rudder wash doesn't directly hit it. You can see these have a diameter of about 4.5 inches, which many of the lights have. In order to mount them correctly, they do need to be on a fairly flat surface. You can put shims in them when you attach them, but again, they lift further away from the hull, and then that creates more drag. You can see we located them basically facing downward. When you buy these, 99% of the time, they're put horizontal to the water line, and they flash out like this. But if we were to put this light, here's the water line when the boat's in the water, and it has to be about 8 inches underwater when it's in a circle flat. We'd literally have to have it like right here. And if you back up, you'll see that we're literally 6 feet under the boat. The hull stops right here, but the mount would have to be here. So that doesn't work. What a lot of catamaran companies and boatyards will do is they'll put it on the curve right here at about 6 to 8 inches below the water line, which is about here. But again, we're still 2 feet away from the bottom of the boat. So majority of the light will be flashed underneath the boat, and you won't be able to see it very easily. And the other problem with that is, again, when you put it as far back as you can, because you want to be able to see the light, you get more and more on this curve, and that becomes a water egress problem. So I didn't want to deal with this at all. And here's the final reason why I didn't want to have one light here and one light here pointing this way. If you look up above me, here's what our transom looks like in a usual way if we're in the water. You can see our dinghy hung up on its davits. You can see the 4 tanks we have for scuba diving and the cooler. When you look at this, you can see that looking in between the 2 davits, even with this beautiful seat that sits right back here in our aft cockpit, that we could come over here. So as I sit down here, imagining the lights were in between both of these transoms on either side, you would see that we'd have to remove the dinghy and have it floating in the water for us to be able to see in between the 2 hulls. But even if that's gone, between all the other paraphernalia we have back here, we really could not easily see into the water. So then we were left with, what do we do back here on each of the transoms? And I elected to put both of them on one side because you can go on our transom and you can see about 270 degrees all the way around. When you see that 270 degrees around and you have both of these lights and they're both kind of flashing down and they're going to concentrate together, I think we're going to have a really beautiful view of the water. And as I started, we will blame me if it doesn't end up being balanced. But as Stephanie said, I can only buy 2 more and have 2 more put in. We put in some Fathom underwater lights. They are the FL12s. They come in white, blue, or white and blue. We put 2 lights in on this starboard side hull. With the switch, you're able to switch it on, and both lights come on, both the blue and the white. And then you hit it one more time and just the blue comes on. Hit it one more time, then the white comes on. On off one more time, and then it flashes kind of like a strobing effect. So it all starts out with locating your lights on the bottom of your hull. Once you finalize where that is, you drill a pilot hole up through the bottom of the boat. At that point, you still can seal up that hole if you need to and move the light. When you're talking about hulls of boat, they're made of 3 basic materials. A bottom, which is next to the water part of the hull, which is a resin fiberglass layer. There is a core layer that adds rigidity and thickness to the boat, and then a top layer of fiberglass and epoxy. In order to put in any type of through hull, you need to pierce through the fiberglass, through the core, and through the next fiberglass in order to create a through hull void. When you create a through hull, you have pierced that middle core. That middle core should never ever get wet. And when it does, it can cause a lot of problems down the line for the quality of the boat. We also know that we have 3 screws that are going to be screwed up through the sides of the light up into the hull, and those 3 screws that hold on the light will also be penetrating through the through hull. Now what we need to do is extract all of the core material from where the screws are going to go up and also where the cable goes through the boat to the electrical panel in order to energize the light. So those 4 elements need to make sure that water, when it touches or goes around those wires or those screws, comes nowhere close to the core. And so a good process of putting in these lights is you have to literally take a 4-inch drill bit and drill through the inside epoxy fiberglass and drill into the core, and then pull and chisel out all the material from that 4-inch diameter until you get down to the fiberglass epoxy bottom hull layer, and you leave that alone. And so what you'll see is a blue area, and that's the backing of the outside epoxy fiberglass hull. And what you'll see is a big open space. Then what the boatyard does is they pour epoxy into this newly created void. And by doing so, it seals up that core on the outsides. Now what you do is you go back and you re-drill that center hole up through the epoxy. You also drill 3 pilot holes for the screws that hold the light on, and all 4 of those holes go straight through epoxy. They don't even come close to any core material, and therefore the boat is sheltered from any possible water ingress from the new holes that we put in the boat. Then it's basically putting caulking on the backside of the light up into all 4 of the holes, running the cabling through the cable hole that allows the electricity to get to the light, and then placing the light up there and screwing it all in, and then letting the caulking cure. And now you have a very watertight light. Once the light is in, everything is cured, then it's a point of running the wire. Our lights are under one of our sugar scoops, and as a result, they're only about 2.5 feet away from each other. The 2 wires come up out of those individual holes. We mate them together, run them through the ceiling of our engine compartment. Then it runs through conduits right back to our wiring panel. We wired it into a switch plate. The wiring itself is quite easy. It's DC. DC is easy to wire in to your panel.
We're currently putting together a review of these new Fathom FL12 underwater lights. So we're going to test them, and we're also going to look at the placement that we use to see what we think of it. So make sure to hit the subscribe button and also the notification bell so that you don't miss our review.